Good morning, everybody. I'm Sandra GÓMEZ-SOLER, and with this work called Experimental Neanderthal Pyroarchaeology, a multidisciplinary and multiproxy approach in the Des-Cubierta Cave, Madrid, Spain, we want to show the importance of the experimental point of view to understand the fire used by Neanderthals. Pyroarchaeology understands fire as an archaeological or anthropogenic artifact with an associated technology, pyrotechnology. The recording of fire is the result of different operational chains with theoretical, methodological, and technical foundation that must be analyzed and interpreted from a transversality of methods. We study different archaeological sites in the center of the Iberian Peninsula, in the north of the Madrid region, and the upper River Lozoya Valley. Its karst system develops in the Cretaceous limestone and dolomites where appeared a multi-level cave system with sub-horizontal conduits. These sites of Pinilla del Valle are in the Caldera de la Higuera, and we identified two hyena dens in Camino Cave and Buena Pinta Cave, and a Neanderthal hunting camp in Navalmaillo rock shelter. But we put the focus in the Des-Cubierta Cave, a large gallery in zigzag without ceiling due to erosive processes. The Neanderthal levels contains an accumulation of class-supported subangular dolomite blocks and carbonate boulders in a sand clay matrix. The archaeological assemblage is dominated by an unusual accumulation of cranial remains or light ungulates with defensive cranial appendages, bovines, cervids, and rhinoceroses. These remains have been anthropically modified, for this is a Neanderthal site with a symbolic interpretation. We also found a clearly Mousterian industry in local raw materials and recovered an immature human mandible and seized deciduous teeth. The assemblage is also dominated by numerous evidence of combustion. We found an area of in situ burn skeleton soil and different concentration of thermal alteration remain, such as bored bones, charcoals, and rubefacted dolomitic glass and sediments. But it is difficult to find conserved combustion structures in the sedimentary matrix. Due to this difficulty, we thought that we needed an experimental model to compare how the remains suffered thermal alteration. We apply a geoarchaeological approach that focuses on the study of sediment alteration and the anthropogenic signature preserved in the sediment after combustion. The biomarkers or biological molecular markers, concretely lipids, are organic compounds preserved into the sediment and we use for tracing signal to reconstruct paleoenvironments. The total lipids were extracted and separated into 5 fractions of different polarity. Through the sampling of intact and oriented sediment blocks from the experimental herds, thin sections are being made to study their components at the microscopic level. The microcontextual approach provides information about the integrity of components, their origin, deposition history, and their relation with human activities. In this case, it applies to combustion structures. We carried 4 experimental herds with different variables that we found in the archaeological site, such as bones, fresh and dry, lithic industry in different raw materials, and the same fuel. In each herd, we documented all the remains included at different dates and their spatial reference were taken before combustion. In herd 1, we placed a circle of dolomitic glass to place the firewood, and we used archaeological sediment, reproducing the glass-supported matrix of sediment of the Des-Cubierta Cave. Fresh bones were included in her too to assess their degree of thermal impact. In addition, in this case, we included a bovine skull to burn in the flames and study the organic signature that these remains leave in the sediment, as well as the thermal impact on the cranial remains. In her 3, when the combustion flames were extinguished and we obtained embers, we thread over then different bone and lithic industry remains. We also placed a bovine skull on the embers until were extinguished. The last of the hearths was the simplest. A bovine head with meat and fat was placed over the flame. We take the temperatures in different points and depth of each hearth during the whole time of combustion, using the specific devices for this task. All experimental hearths were excavated with archaeological methodology and sampled according to the protocol for sediment lipid extraction. For this, we obtained a stratigraphic section of each hearth and documented the thermal impact on the subsoil according to the color change. The biomarker shows the effects of having meat and fatty elements used as foil, fuel, or cooked meals in the generation of new molecular combustion products in herbs. Alkanes and aromatics concentration decreases with high temperatures except when there is animal fat involved. The production and study of the thin section of the experimental herbs is in progress, but with them we will be able to characterize the type of thermal alteration of the archaeological sediment and compare it with the same pulse from the Cueva Descubierta. After a macroscopic analysis, an evident modification in the color of the lithic remains after combustion was observed. So we are carrying out different analyses that will allow us to know the structural and chemical modification of these raw materials due to the thermal impact. The preliminary study of the modification in the cranial and postcranial bones shows an evident change of color and degradation of the structure due to the thermal impact. An in-depth taphonomic analysis will allow us to create a frame of reference of the thermal alteration of the bone remains depending on their exposure to the heat focus. To this end, this study will be complemented by an exhaustive spatial analysis study. Finally, combustion affects all types of material involved in the experiment at a macroscopic and also microscopic and structural level. It's necessary to establish a relief experimental model to compare it with the archaeological remains and categorize the thermal impact. The archaeological approach with the micromorphological analysis and lipid biomarker analysis have the potential to discern archaeological barn sediment and their degree of thermal alteration, giving insight on the intentional production and use of anthropogenic fires. The creation of a comprehensive frame of reference for the degree of thermal alteration of the material will allow comparison with the archaeological patterns of the Des-Cubierta Cave and an understanding of neanderthal behavior in relation to fire. Thank you very much for your attention. Finally, we want to thank the Ambilab and the Pinilla del Valle teams for the technical support and special thanks to all persons that participate in the experiment.